So we cannot talk about electricity without talking about electric charges. And when we talk about electric charges, we go back to the basics. We go back to the atom. We talk about sorry, it's like my location is too noisy. I'm coming. So we talk about the charges. We talk about the atom. We remember that an atom is made up of positive. We can ignore the neutral neutrons and speak more about the electric. Oh my Lord. Sorry, we can ignore the neutral neutrons and focus on the positively charged protons and the negatively charged electrons. So like we have established that the electrons are negatively charged. They carry a charge of 1.602 times 10 raised to power minus 19 coulomb. Similarly, the protons also have a charge. They have charges of 1.602 times 10 raised to power minus 19 coulomb. So that is to say that the a proton and an electron, they have the same charge magnitude, but different nature. The electron is negative, while the protons are positive. So for that reason, we can say that those are the two major charge carriers in an atom. So in our day-to-day activities, we come across the effect of charges around us, especially in the Harmattan period. You notice sparks. You notice different sparks in your clothing or around you. When you fold some clothes together, you see electric sparks. Those sparks are as a result of charges leaving one body to the other. So we have charges all around us. But when we have equal number of positive and negative charges, we say they are electrically neutral. So also we should remember that fine, we said a proton has a positive charge, but a proton is very heavy compared to an electron. A proton is about 1,800 times larger or heavier than an electron. So what that means is that electrons can be pictured as very responsible for the ability to move around easily and move around freely. So the nucleus of an atom is like the dense center of our solar system, while the electrons are just like the small planets that revolve around the solar system. So the tiny electrons are responsible because of their mobility. They are the ones that move around. Then we can say they are the major participants in electricity. So we should always remember that the charge of an electron, be it electron or proton, is 1.602 times 10 raised to power minus 19. Sorry, please. 1.602 times 10 raised to power minus 19 coulomb. So because it's an electron, it has a negative charge, so you may call it minus 1.602 times 10 raised to power minus 19. And as a proton, it's going to be so when is an atom said to be electrically neutral? When we describe an atom, it's easier to say, to picture it. I want to get something like a writer, pen, red pen. We can imagine an atom to be made up of a positively charged nucleus, which is enclosed by orbits where electrons move around. Let me protons. So now okay, let me go back to red. So let's imagine that at the center here, we have 11, let's say at the center here, let's say we have 11 protons. And let's say that around at the orbits, all around, we have 11 electrons. So that should tell us this is a sodium atom. So now the number of positive charges, we have said earlier that the charge of an electron is 1.602 times 10 raised to the power minus 19 coulomb. That is the magnitude of the charge. For an electron, it is negative, while for a proton, it is positive. So we can now conclude to say that what is the net charge? What is the total charge in this sodium atom? What that means is that it's like you have 11,000 naira in First Bank and you are owing GTB 11,000 naira. Then the question is, how much exactly do you have? Easily we can say you have nothing. It's until what you have in your pockets is greater than what you are owing the one that sells food and the one that sells clothes. That is where you can easily say that you are rich or you have money. But you cannot be boasting that you have 5 million. Talking about sodium and chlorine reacting. And one of the things they tell us is that one electron will leave sodium and go to chlorine. When that happens, it's as good as we saying that this particular electron leaves and goes to chlorine. When that happens, we will be left with 11 protons and 10 electrons. So when we have 11 protons and 10 electrons, then the net charge will be said to be +1 because we have 11 positive charges and 10 negative charges. So the net charge can be said to be +1. And the sodium atom is no longer a neutral atom any longer. It is now an ion because it is not having equal number of protons and electrons. So for that reason, we can say that it is now an ion. So the chlorine as well, which originally had, let's put one corner here. Sorry. Let me take one corner here for chlorine. Chlorine, which had 17 protons, 17 electrons originally. As we can call the chlorine atom originally had 17 protons and 17 electrons. That can be said to be electrically neutral. But when the chlorine receives 1 electron from sodium, then the number of electrons increases from 17 to 18 electrons. So if we now ask, what is the total charge of chlorine? It is having 17 protons, 18 electrons, 17 positive charges, 18 negative charges. That means that it is having a net charge of -1, because 17 plus -18, that is -1. So because it's having a net charge of -1, it can also be regarded as an ion. It can also be regarded as an ion. And but in this case, we can no longer call the sodium and the chlorine neutral atoms anymore. They are now ions because sodium has lost an electron. It is no longer neutral. Chlorine has gained an electron. It is no longer neutral. So we can now say Na, it has lost an electron, plus. And the chlorine, it has gained an electron, minus. So sodium ion here is regarded as cation, while chlorine ion here is regarded as anion. So we can say that an ion is a species of atom that has lost or gained electron, whose number of protons is no longer equal to the number of electrons. That can be as an ion. And if it is cation, it is positive, or if it is anion, it is negative. As it is cation, it is deficient of electrons, that is having excess of protons. And it is anion, it is having excess of electrons compared to protons. So let's move ahead. Let's see what we can do. Let me take the time. Wow, we still have time. There is still hope. Okay, the basic properties of charges. Like charges repel, while unlike charges attract. And in physics, we don't just talk about the quality or we don't just describe nature by saying attract or repel. We like to quantify. If you say, oh, I'm attractive, how attractive? What is on what scale? You cannot just say it's attractive. You have to mention on your meter or with your attractometer to say that this is the level of my attractiveness, or and if I'm repulsive, or if I'm ugly, on your uglyometer, you must have a measure. We don't just talk like people in some other fields that I will not mention for security reasons. So you have to, in physics, we quantify everything, including forces. And when we say something is attracting, if I say, oh, rice and dodo is attracting me, I should be able to say the level of attraction in newtons. How is it attracting me? So there should be quantity. So in physics, we talk about quantity. We quantify everything that surrounds us. Just like in Coulomb's law, it will help us to determine the amount of attraction between two charges. So when we say attraction, attraction is a force. And when we say repulsion, repulsion is also a force. So, and when we say charges, charges are quantized. When we say charges are quantized, it means that for every amount of charge, it is units. The basic charge you can have is 1.602 times 10 raised to power minus 19 coulomb. Every coulomb is the unit of charge. Every other charge you can have must be an integral multiple of the charge of an electron or proton. So that is the basic unit of charge. So it's if somebody tells you that a body has a charge of, if somebody tells you that a body has a charge of 2.0 times 10 raised to power minus 19 coulomb, such person has lied. There is nothing of such. Every charge you have must be an integral multiple of 1.602 times 10 raised to power minus 19 coulomb. And another property of charge is that charge is conserved. The origin of charge is from the charged particles, which are the protons, the electrons. And you must have heard it in one place or the other that you cannot destroy matter. If you cannot destroy matter, you cannot create matter, you cannot destroy. So and also charges, you can move charges from one body to the other. You cannot destroy it, you cannot create it. So that is one of the properties of charge. So they are conserved, they are quantized, and they attract or repel themselves based on Coulomb law. So to determine the presence and nature of charges, the device that is used is called the electroscope. Okay, I got this diagram from a book written by many lecturers in the Department of Physics, and I will give, it's part of the list of books I promised to give you. So, and it was edited by two professors, Faraye and Rooney. So let's go back to the diagram here. The diagram here is an electroscope, or to in full, let's call it a gold leaf electroscope. Get this pointer. So in the electroscope, this is the metal disc, this is deflection arm, or some can call it the gold leaf, and these are metal rods. So if you bring a particular charged body to, let me bring a charged body. If I bring a body that is positively charged, if I bring it close to this metal disc, the positive charges will spread into the metal rod and the deflection arm. Since they are positive charges, they will repel themselves. And because they will repel themselves, it will make this deflection arm to move away. So originally, this deflection arm was standing vertically upright. The deflection arm was originally standing vertically upright. But when charge material, let's say positive charge in this case, is brought close to the metal disc, if it's brought close, then, or let's say even, let's just, well, if you use it to touch it, let's say use the metal disc to touch it, then positive charges would be, the excess positive charge will flow into this place. And for the fact that the metal rod and the deflection arm are having like charges, then we would expect repulsion. And the repulsion will cause the deflection arm to bend away. If the magnitude of the charges that have entered this place, if it is large, then you would expect this deflection to increase. And if it is just a small amount of charges that flowed into the metal rod and deflection arm, it will only deflect a little. So the deflection, the angle of deflection, helps to quantify the amount of charges to the metal disc. So there, I think from this page, we should be able to have a better understanding of charges and their interactions. So let's deal with what we have in this corner, the A, interaction between plastic rods rubbed with four. So now what we have here is a plastic rod that is hung on a particular, it's hung, let's say, tied to your retort stand. It's standing, it's tied, is standing vertically, sorry, horizontally, and you bring another plastic rod close to it. It makes no meaning. You have brought a plastic rod beside another plastic rod. There is nothing special about that. Nothing will be experienced due to you have just brought two things beside each other. Nothing special, nothing so special would happen. But now when you take when you take wool, you use it to rub the two plastic rods. When you use wool to rub the two plastic rods like we have here, the wool is going to transfer electrons from itself to the plastic rods. Because you are rubbing it, some electrons will be transferred from the wool to the plastic rod. And what that means is that the plastic rods will now be negatively charged because the electrons have been transferred to them. They are now having more electrons than they had before. Their protons are still intact. They still have the same number of protons. Now, because you have used wool to rub both of them, you have transferred extra electrons on the plastic rods. By doing that, the plastic rods now have excess electrons. The plastic rods are now negatively charged. So when you hang one of them to stand horizontally, when you bring the other one close to it, just like what is happening here, they are both like charges. This plastic rod will push this other plastic rod away. It will repel it away because they are like charges. So something special will now happen because both plastic rods are no longer neutral. They no longer have equal number of protons and electrons. They now have more electrons than protons. So their net charge is negative. For that reason, the plastic rods will repel each other. So that's for this scenario. Let's talk about another case here. In this case, we have two glass rods. The two glass rods were brought close to each other. It makes no difference. It makes nothing special. It's just like you having two glass cups, putting them all in a tray. There is nothing special about that. But when you take the two glass rods and you rub them with silk, or you take the two glass rods and you rub both of them with silk, or you rub them separately with silk, but in never way, you have rubbed them with silk. By doing that, the silk is also like a cloth. The silk is going to take away parts of the electrons on the glass rods. By using silk to rub glass rods, the silk material will take away some of the electrons on the glass rods. By taking some of the electrons from the glass rods will be deficient of electrons. The glass rods will be having less of electrons than protons. The glass rods will be having a net charge that is positive. And the glass rods, when now brought beside each other, they would also repel because they are having like charges, and like charges are expected to repel. In the first scenario here, the 4 added electrons to the plastic rods. But in this second scenario, the silk removed electrons from the glass rod to make the glass rod positively charged. The first scenario, the wool added electrons to the plastic to make them negative charge. So that means that, like we said in the property of charges, that they are conserved. Charge should be conserved. That means that the excess electrons that entered this plastic rod did not come from anywhere. They came from the 4. They came from the wool. So that means that the wool, which has given electrons to the plastic rods, is now positively charged. The wool that gave electrons to this plastic rods is now deficient of electron itself. So the wool, or the 4, is now positively charged. And in this scenario, we have used silk to rub glass rods. The silk has removed some electrons from the glass rods to make the glass rods positively charged. The wool has removed the electrons. The electrons that were removed did not disappear. They entered the silk. That means the silk is now having excess electrons than it had originally. And that will make the silk to be negatively charged. So let's come to, I would like to stop early at least so that if we have questions, be able to go around them. So now let's come to this third scenario. We have the plastic rod that had been rubbed with 4, making it negatively charged. We also have the glass rod that has been rubbed with silk, which is now positively charged. When both of them, the rubbed plastic rod and the rubbed glass rod, when they come close to each other, they attract because they have opposite charges. They are oppositively charged. For that reason, they attract. And what we have over here, okay, this is the glass rod and the silk. The glass rod being positive and the silk, which was used to rub the glass rod, is now negative. So they are unlike charges. They will also attract. And in the last diagram we have here, which is synonymous to the first diagram here, the wool, which was used to rub the plastic rods, is now positive. Well, because it has lost its electrons to the glass rod, or to the plastic rods. And now the plastic rods and the 4 now have opposite charges. If they have opposite charges, then they should attract. That is the law. That's the law of nature. Unlike charges attract, like charges repel. One of the things why I like physics is that it extends to every part of life, especially the kitchen. Rice and beans attract, rice and yam repel. Well, let's move ahead. Let's move ahead. But I know when we get to Z-code, rice and yam would still attract anyway. So let's move ahead. Let's talk about some materials, classes of materials. We have insulators, conductors, semiconductors. We also have superconductors. And we'll say conductors, they are materials that allow free flow of electrical heat energy, while insulators, they prevent easy flow of heat energy or electricity flow. And semiconductors, they are best defined with electricity, not with heat flow. And in semiconductors, they allow electricity to flow better than insulators, but not as good as conductors. And the way the condition with which they perform depends on many other factors. And superconductors will not even impede the motion of electrons to allow electrons to move freely. So let's talk briefly about polarization. Let me take the time. Okay, polarization is the process of separating excuse me, is the process of separating opposite charges within an object. This usually involves the use of charged objects to induce electron movements or rearrangements. So let me get okay, I have a pointer. So this, if you look at this particular sample, it is having some atoms, and the atoms positive and negative, they are disoriented. They are some positive charges are pointing to the left, some to the right. They are pointing in any direction. They are not orderly. But if you come to look at this sample at the base of this corner, the sample here is polarized. And why is it polarized? Because it is exposed to an electric field. So in the presence of an electric field, in the presence of an electric field, where positive part of the field is from the top, and negative part of the field is from the bottom, it is easy for you to see that the atoms have turned. The positive part of the atoms have somehow turned, pointing, even not direct, but pointing to an extent towards the negative part of the field, while which makes the negative part of the atoms to point towards the positive part of the field. So these atoms, the arrangement here appear to be more orderly compared to the sample that is unpolarized. So methods of charging. We have different methods of charging. One is by conduction, and that involves the contact of a charged body with a neutral object, and it is useful for charging conductors. So you have an object that is charged. You have an object, a neutral object. Neutral object is the one that have equal number of positive and negative charges. And you now bring another body that is having, let's use excess, that's having excess electrons, so much excess electrons. When this comes in contact with, when they come in contact with each other, part of the negative, or part of the electrons, or part of the negative charges here will flow to the, part of the negative charges here will flow to this particular neutral object, and it will make it negatively charged. So there is also charging by friction or rubbing. Charging by friction or rubbing is similar to what we discussed on this page. These objects, the glass rods and the plastic rods, were charged by rubbing. So that's the brief summary of what happened there. So it involves rubbing of materials against each other, just like we noticed with the four and the plastic rod. So and that's what followed was the transfer of charges, transfer of electrons from the four to the rod. And on the other hand, where silk was used to rub glass rods, transfer of electrons from the glass rod to the silk. So we also have charging by induction. Charging by induction is charging by induction involves there is no contact. You just bring it close. And when you bring it close, there is polarization and with some grounding. So I would like to stop here so that I would entertain questions. I think I have some things in the chat. Are you trying to explain? Okay, I think there is no question in the chat. So I would like to entertain questions before.
Good morning, sir.
Okay, good morning.
Human beings charged. Is the human body charged?
Please, I can hardly hear you. Please speak up. If you have a question, you can unmute yourself and ask. Before the end of the class, let me appreciate our host, Judith Okeago, for being so wonderful today.
Good morning, sir. Please, when are they going to release our physics result for the first semester?
It's like, can you speak louder, please?
Physics result for first semester.
Please, that's not part of the course content. We are talking about
Physics.
Talking about I'm not here to discuss results. I'm here to discuss electricity and magnetism. That's why I'm here, please. Some of you're only.
Good morning, sir.
Sir.
Good morning.
Ajax is human body charged, sir.
What's it?
No. I said human body. Is it charged, sir?
No, human body is made up of charges. Human body is made up of charges. Fine, that is right. So just like anybody, then the question is the net charge, is it greater than 1? Is it less than 1? If the net charge is 0, then it is neutral. Is it greater than 1 or less than 1? So it depends on different conditions. So it depends on different conditions. So
Please, will you drop the slide on LMS?
During the Hamatan, you walk past the doorknob and there is a spark. If there is a spark by the door, then that means you've either lost or gained charges. So just like anybody, just like any material, you can be charged as well.
Okay, so you talked about charges being quantized.
You have to leave up so that some other people will be able to use the room. So once again, thank you. Please help us end the class, closing the class. So that, some other people will use the class.